So my name is Thibaut Sardin, and I want to talk about Polkadot and Substrate. Before I do this, I would like to know who of you has heard or is familiar with Polkadot. Can you raise your hand? Awesome. And so for you to know, it's like 20%, 25%. And who of you is familiar or heard about Substrate? A bit less than the 20% before. So I will try to not go too fast. The things is those two things are really big. Like it's two big topics, and I will just scratch the surface. And if there's anything that you're interested in, I'm happy to dig in with you in the questions. So first of all, I will start with this statement that specializations breeds optimization. This is something that I think is actually very general, not only applies to blockchains. When you do one thing, and you do only one thing, usually you optimize it. You spend a lot of time on it, or at least enough time so that you're happy with it, and you optimize it. And when you try to do several things, like a lot of things at the same time, or try to cover a broad scope, then you might maybe not optimize it as well and not do it as well, as good as if you had several people doing one simple thing. And this is something that we keep in mind, and we had in mind from the beginning, from the start when we started to work on Polkadot. What we've realized is that today we have so many different blockchains, and many blockchains do try to do a lot of things, and some of them try to do also one thing. Let me take an example like Zcash, right? Zcash does one thing very well, or try to do it very well. It's like privacy, trying to send some Zcash over without knowing how much is sent and who has sent it, etc. And the thing is, we see a lot of blockchains that try to do a lot of things, and the problem is, well, it's not very optimized, and there's not one blockchain that achieves everything. You cannot have like a very good privacy and, I don't know, like smart contracts, for instance. So this is a problem. And all of these chains that we see have very different objectives and very different state machines. Just realize I'm actually standing in the way. You might not see me. Should I stand here?
Stand
but
perfect.
Then I'm far. Yeah. Okay. So these, what we call state machine, I will talk about this word a bit more after. It's really what makes the state of the blockchain evolve. Why Bitcoin block can have some transactions, and why it evolves to another block. Why are transactions accepted, etc. in a block. And so, as I mentioned today, I feel like we have a lot of different blockchains that are doing different things with different state machines, different consensus, but they're all like bubbles, like these bubbles. They really don't interact with each other. They don't know about each other. Maybe the developer who built them know a bit and try to take smart things from each other, but like when you're on Bitcoin or on Ethereum, you cannot really talk. Like Ethereum has some cool things that you can do, such as bridges, but it's still like it's always, you always have to go through a centralized like kind of a centralized entity to move from one chain to another. So in the end we end up with a bit with, oh, Dimitri is there. Awesome. So you end up with kind of the silos that we try to actually escape with these decentralization. So we really need, what we really try to do is solve this problem of interoperability with Polkadot. We really need interoperability. We really need these blockchains to talk to each other. And yeah, so that's Polkadot. For those of you who don't know what it is, actually, I think I have a slide. Yeah, exactly. It is a protocol that allows independent blockchains to exchange information. So, yeah, think about it. So I hear about it every day, so I know what it is, but I feel like the first time I heard about it, it was actually not very clear what it was. So protocol that allows independent blockchains to exchange information. So you can think about these different blockchains like trees in a forest, And those trees don't really talk to each other, they never connect. And you will have this protocol, this Polkadot, that allows actually those blockchains, those trees to be connected, like on the ground, for instance. And so it's the same, but said differently. It's an interoperability layer that enforces order and the validity of messages between the chains. So it's basically a way for several different chains to talk to each other, to exchange messages. How do we do this? So it is yet another blockchain that kind of allows us to do this. So if you see here, there's a big relay chain in the middle, and this is a blockchain whose purpose is basically to exchange messages between other blockchains. And these other blockchains, the trees that I was talking about, were those parachains. So as you can see, they are a bit different, like each parachain is different, and we want these parachain to do one thing very well. So we really hope that we will have one parachain that is very good at privacy, one parachain that is very good at, I don't know, like maybe a smart contract, or one that is very good at doing some identity things. And this relay chain in the middle, it is a blockchain that allows to send arbitrary messages between those different parachains. And because we don't want to just forget about what we've built before, meaning Ethereum, Zcash, etc., we might for some parachain, we might for some blockchain be able to build a bridge, such as here for Ethereum. It's quite easy actually, because Ethereum has a Turing complete virtual machine, so we can do almost anything we want. So we can build a bridge to this Polkadot ecosystem. The whole thing is the ecosystem. I forgot to click. So the relay chain in the middle, the parachains around, and the bridges to interact with third-party chains that were built before Polkadot. So one thing that Polkadot brings, which is really awesome when you want to build your parachain, it is what we call pooled security. Today, when you build a blockchain, you have to build the whole community to secure your blockchain, right? When you have like Bitcoin, when you have Ethereum, or here I took as an example Litecoin and Zcash, you have to have like, for proof of work, you have to have some miners. You have to have a community of persons who will dedicate some mining power. The thing is, they cannot, like if they try to secure Zcash or if they try to secure Litecoin, they cannot do it at the same time because it's proof of work. And actually, because they spend a bit on Zcash, they are actually lowering the security on Litecoin, which is really sad. This is something that we can solve with proof of stake, and that's what we use on Polkadot. So basically, when you come and build and connect your blockchain to the Polkadot network, when you come and add one of the trees to this forest, you will benefit directly from the security of the network, meaning that the validators, these guys on the top, they will share their validating power. I don't know how to say this. They will basically share their security. The security will be shared among all the blockchain that take part in this Polkadot network. So when you come and join Polkadot with your blockchain, you do not have to bother about security, because this is something that is provided by the network. So we really want to be inclusive here and connect the dots or the bubbles. And yeah. So there's one thing that we did when we built Polkadot. So Polkadot is a project from the Web3 Foundation, and they have basically asked to Parity, or like one of the founding member is the same in Parity and Web3 Foundation. We've been basically asked to build the first implementation of Polkadot in Rust. And Parity Technologies has been building blockchains for a while already. So the founding members of Parity actually built the first C++ implementation of Ethereum. Then they built it in Rust, and then we also built a Bitcoin implementation, which is called PBTC. And recently you might have heard that actually Parity will be the Zcash implementation also. This has been asked by the Zcash Foundation. So we've been doing this for a while, building blockchains, and it's kind of all the time the same. You have to like it's not copy pasting directly, but you have to really do the same things. Like you have all the sync to care about, the networking. It's done on dev P2P on one side. On Polkadot, we use libp2p. You have to build, I don't know, all the CLI, all the RPC, all the storage, and you just redo it all over again. And because we've done this for a while, we have a lot of knowledge on this, and we thought, okay, now we're going to build, for instance, for Polkadot, the relay chain, and we're going to do it again? No, not this time. This time we're going to build a framework to do it. So that's Substrate. So Substrate is very, very different than Polkadot. It's like Polkadot is the network to connect parachains between each other, and Substrate is really a library, a framework. Actually, I have a slide for this. So it's a general purpose blockchain development kit, and it's written in Rust because everything we do at Parity is Rust. So this is really kind of, a framework to build blockchain, but not only for Polkadot, and that's the really interesting thing. You could use this today to build your own chain. You do not have to build it with Polkadot. You can build your community and care about, I don't know, security and stuff. Even though Polkadot gives it to you for free, you can kind of use Substrate to do your own chain. We call it solo chain, and not plug it into Polkadot. And so what Substrate does is giving you all these tools that I was talking about before, and I will mention them right after, that you kind of have to build them anyways if you want to build your chain. It's just that they are here and given away for free. So when you think about blockchain, I was talking about all these different blockchains before. There are a couple of things that make one blockchain very different to another. One of these things is the consensus. So it could be proof of work, proof of authority based, proof of stake. Basically, this is what makes, for instance, I don't know, like EOS very different from Ethereum, because one is dedicated proof of stake, the other is proof of work, and this is like some kind of also marketing scalability marketing language. There are a lot of things that go into this. There's also what I was talking before, the state machine. So this is really why Bitcoin is Bitcoin and why Zcash is Zcash. I mean, in the end, you're sending tokens, right? But why is Bitcoin Bitcoin? Well, because it's based on, I don't know, like UTXO, and because you can like aggregate some different UTXO and say, okay, I want to spend this. Or Zcash has all this privacy and ZK snarks. So this like consensus state machine is something that you kind of have to build. Like if we give you the tools, Substrate, to build your own blockchain, you still have to kind of build what makes your blockchain unique, right? And this will be in the state machine, for instance. So now I'm going to list all the things that you get with Substrate. So one thing which is a bit complex to understand, it's called SRML. It's for Substrate Runtime Module Library. And it's a set of library, a set of tools, a bit like, think about it, just like Lego. You can just take it, a library, take it, plug it in, and it should work. So there's this, of course, interconnection between chains that you get out of the box, because we built Substrate for Polkadot, so you get it, and it means also that if you use Substrate, you will be able to plug it to Polkadot, your parachain, or your chain, sorry, you can plug it to Polkadot very easily. There's a hop-swappable, pluggable consensus. I was talking about consensus right before. What makes a blockchain very different from another is very often the consensus. Here we have a pluggable consensus, meaning that you can use kind of the consensus that you want. We do have a couple consensus built in already. One is called Grandpa. It's a bit like Casper with like some block production decoupled with the finality gadget. I will not talk about this, but we have interesting things online if you want to hear more. And then there's the light client, meaning that you can have, for instance, mobile to sync with the top of the chain quite easily. Right now, having a full node is already for if you if you heard about Ethereum, for instance, that, I mean, at Parity we're building a full node for Ethereum. It's really a pain in the neck, and you definitely cannot run it in a mobile. If you use the light client, however, even for Ethereum, you kind of can already use it. And we give it for free also with Substrate. There's exchange synchronization, the PubSub to build UI on top of it, transaction queue, the networking, which is built on libp2p, so it means that it can be implemented in the browser pretty easily. On top of the Rust implementation, sorry, that's a long list, that's annoying. On top of the Rust implementation, there's a JavaScript implementation also. There's telemetry, which is basically a way to see which node is connected to the network, etc. And last but not least, I will spend a bit more time on this one, a upgradable runtime, chain runtime. That's a very fancy name. We couldn't find a better one, actually, so I will spend a bit more time about this right now. What does that mean? So runtime. First, I will try to talk about this runtime. So runtime is really like a bit like the state machine. So it is the software that will understand all the transactions that come in. For instance, I was saying Zcash. In this software, in the core of the Zcash blockchains, it knows. She said I have 5 minutes. I'll try not to be too quick, but that's fine. I'm pretty sure. So it knows basically for Zcash, okay, how to validate Zk snarks and how to know that you are actually the person you pretend you are and you have the money you want to spend, etc. So this is the runtime. This is the core of the blockchain. This is what knows how to go from one state to another, which understands the transactions that are sent around. And the runtime in Polkadot and in Substrate has to be written in WebAssembly. I will go pretty quick on this one, because if you don't know what WebAssembly is, I'm pretty sure after my talk you will still not know what it is, and that's okay. So it's a really clever thing that runs in a browser and is extremely quick. So it can be built out of C, C++, and Rust. So basically you build your program in C, C++, or Rust, boom, you compile it to WASM, and WASM is awesome because almost everything can run this binary, this executable. And the runtime I was talking about has to be built in WASM. So basically you build it in C, C++, Rust, and you compile it to WASM. So hot upgradable runtime, I was saying. So this runtime, you have to build it. That's the thing that you build. We give you like everything that's around, and we let you build the runtime because that's what makes your blockchain so unique, right? And it has one function which is exposed to the outside, to the substrate, and that's execute block. And this function is really cool because it can allow you to upgrade itself. So basically, this WASM runtime, what you have built, you can basically tell itself to, okay, starting from next block, you will not use this executable, you will use another one. So you basically replace, a bit like, I don't know, when you upgrade, or you don't even see it, right? When you upgrade your browser, Chrome, you just shut it down and turn it on again, and then it's the new version, you didn't even see it. Okay, this can happen without shutting it down and turning it on again with this hot upgradable runtime. And we did actually use this when switching from our proof of concept 1 to proof of concept 2, so those are testnets that are live today already, and we did use this, so we did an on-chain upgrade. I have probably 1 minute for this one. But it's actually really interesting to understand, okay, how do I do when I have so I have nodes that runs this blockchain, and today we have a lot of problems when we want to upgrade the blockchain. We have all these nodes that needs to be upgraded, to be updated. And we have really fancy way, because it's WASM again, because it's so cool, we have really fancy way to actually make sure that all the nodes, even the old ones, can run the latest WASM, the latest runtime, the one you want to upgrade. Basically, this will happen this way. The client, the node, will always ask on the chain, okay, what is the latest runtime? And this is stored on chain in WASM. If you have natively the latest, then you will run the native one, so it will be very, very quick. And if you do not have it, you will run the WASM one, which is stored on chain, which is quick, but not like awesomely quick. I think that's it. If you want to know more, parity.io/substrate, and yeah, I'm here still for questions in this wormhole thing.
Hey, thank you very much.
Thanks for the presentation. You're trying to build an encompassing relay chain, like connecting all the blockchains. So what you're trying not to do is that each of the blockchains out there are connected to each other, but they're like centrally connected. And you have this pooled security, right?
Yes.
So isn't there like a huge centralization risk? Like, for example, if the consensus on the relay chain is broken, I mean, I guess there could be some attack vectors to the network, or the random number generator is broken. Wouldn't that mean that all the other connected bridge chains and parachains stop working?
Absolutely. So it's not because the relay chain is broken that the parachain don't work, but if the relay chain is broken, it doesn't relay anymore the messages. So this is a very good question, and that's something that I also ask myself when I say, hey, we see so many different blockchains and they don't talk to each other, or when we say, okay, they are trying to do everything. Well, Polkadot is not trying to do everything, but it's trying to let people do one thing and allows people like the whole to do everything, so to say. So this is a very good question. We have like fail-safe. We have governance on top of this relay chain so that people can vote, people can propose, and we have like, this is actually very complex. And we really hope, like we have fail-safe also, like if we, let's say, break the relay chain because we did a hot upgrade and there's nothing is working anymore. We have some kind of fail-safe so that if no block is created, for instance, in the next 2 minutes, even though you have a 5-second block time, it will, for instance, roll back. Yeah. So there are plenty of clever things that we could do. If we kind of broke it, but not totally, maybe we will be able to hot upgrade again to fix it. So this is like, come and break it, please. We have a testnet for this.